Hello and welcome to this presentation about running SAS workloads on Amazon Web Services using clustered file systems. My name is Dilip Rajan and I'm a Senior Partner Solutions Architect at Amazon Web Services and I work within the AWS Partner Network. I work routinely with customer engagements for sizing SAS workloads on AWS and I also build partner solutions at scale on AWS. Prior to AWS, I used to work for Amazon.com in their fulfillment technology division, and I helped move their Oracle data warehouse to Redshift while building the next generation of analytical technologies at scale on AWS. As I mentioned on the previous slide, that I work with customers' requests to size SAS workloads based on AWS's and SAS's joint recommendations for the hardware. I also routinely partner with our AWS products and services teams to design our storage and compute requirements to meet SAS's unique I/O patterns as well as throughput needs. I have written white papers and blogs in the past for newer storage solutions such as FSx for Lustre. In early 2020, we started working very closely with Amazon Elastic Block Store service team that to find a option that could scale or exceed the performance requirements of 100 megabits per second per physical core without striping multiple devices together. I'm glad to announce that in reInvent 2020, AWS launched EBS Block Express, which is currently under purview. Over the last couple of months, we have spent hundreds of hours of testing to find the right combination of storage as well as IOPS that would meet and exceed the benchmark requirements for running SAS workloads on AWS. In this presentation, we shall go over some of those latest offerings and share our performance observations and recommendations. Let's first go through a quick overview of our AWS storage options. AWS has helped customers like Netflix and General Electric, Pinterest build or migrate their entire applications on AWS storage options. That's why AWS storage is so broad and deep. It's feedback from over decades of use of scale that drive 90 to 95% of our roadmap. And we have learned a lot. I wanted to share some observations of adoption patterns that we see for our customers and how their cloud journey can be used for other customers as well. Let's talk a little bit about rehost. This is typically a lift and shift type approach where you take your workloads and deliver it on virtual machines and migrate it as is on AWS. It's a great way to get some quick wins, which can be done traditionally with Amazon's EBS or Amazon's EC2. Replatforming is lifting or your existing application to the cloud and adopting bits and pieces of the new AWS platform to change your application. In the database world, you could spin an EC2 instance, install MySQL, and then migrate a database. However, you could also replatform using RDS service and let AWS manage that database for you. In the storage world, that would mean that taking an existing application that depends on an underlying shared file system that an on-network network attached storage system might provide and spinning up a new EFS type file system that can be a drop-in replacement for the application storage layer. A fully managed file systems like EFS removes all of the provisioning and administrative overhead of an on-premises product and lets you focus on migrating the application itself to the cloud. This allowed the BBC to migrate the red button service to the AWS cloud without having to spend their time or money to rewrite core components that depend upon a POSIX compliant file system, and for less cost than running their on-prem NFS server. This approach also allows you to get those quick wins. You're still using similar technologies, but have moved over to a managed implementation like EFS, and it's very easy for optimization as well. Finally, let's talk about re-architecting. This is about building your application to take the full advantage of AWS's cloud services. This also applies to any application that you are writing today. There is no reason that you should be writing your new applications not in the cloud. You get the advantages from the start, but it's also game changing for your existing business critical applications. Many times, this is used as a way to modernize applications you have been running for years. FINRA is the regulatory body of the US Stock Exchange. 5 years ago, FINRA started moving itself to the cloud. They looked at different options for their cloud journey. They could have started with any of the options you see here, but decided to go with re architecting their core application to detect fraud within 24 hours of market close. They did that because it was important not to. FINRA believed that they needed the cloud for their core of their mission, which was to be the watchdog of the consumer investor, and the only way to do that was to achieve the maximum agility that they could possibly get. And now, FINRA is doing 500 billion validation checks on trades daily, all running on AWS. And it's fairly common to use one or more of these patterns together when charting your course and journey to the cloud. To fit any of these use cases, we have developed a number of portfolio of storage solutions in the cloud, spanning file, block, and object storage services, as well as hybrid cloud and data transfer solutions. And we are constantly adding new services like Amazon FSx for Windows, Amazon FSx for Lustre, or AWS Backup that allows you to centrally manage and automate backup processes for AWS resources such as EBS volumes, RDS databases, Dynamo database tables, EFS file systems, and storage gateways. But we don't just provide you the largest number of services. Much of our innovation has been poured in the depth of features and functionality in those storage services, like a new storage class for EFS that saves you 85% on infrequently accessed data, or a deep archive using S3 Glacier. Now that we have looked at the storage options, let's talk a little bit about the SAS workload and its performance requirements. SAS is a very unique workload with its I/O patterns and performance throughput requirements. From a compute perspective, SAS recommends a minimum of 8 gigabytes per physical core of memory, and from a file system expects a minimum of 100 megabytes per second per physical core with an I/O block size of 64 kilobytes. Over the last 3 to 4 years, AWS compute instances have continuously evolved, and AWS and SAS jointly recommended instances such as i3-EN family, or M5 family, or the R5 family of instances, with a block store option such as IO1 with 32K IOPS or ST1 at 12.5 terabytes. You see, given the limitations of both EC2 instances as well as the storage options, the only way to achieve the throughput requirements for a SAS workload was to RAID multiple block devices together, which comes with its own challenges in terms of I/O merges and increased queue depths. The result is that you might struggle to maintain the overhead of striping multiple devices together. For a shared file storage workload requirement in 2019, AWS came out with FSx for Lustre with persistent storage that exceeded the performance requirements for SAS workloads overall. In fact, the performance was so good that we confidently recommended last year that SAS Work, SAS Data, and Utilog, which are all of SAS's libraries, could entirely run on FSx for Lustre without having a requirement to have ephemeral or NVMe storage. This can have a significant cost reduction on the customer's SAS hardware bill. So now that we have seen the performance requirements of SAS's workloads, let's pivot towards Block Express and see what that's all about. Amazon EBS provides 6 volume types: provisioned IOPS SSD, IO1 and IO2, general purpose SSD, GP3 and GP2, throughput optimized HDD, and cold storage HDD. These volume types differ in performance characteristics and price, allowing you to tailor your storage performance and cost to the needs of your application. The average latency between EC2 instances and EBS is in a single digit millisecond. The IOPS performance of IO2 and IO1 really helped customers move even more of their demanding applications to the EBS. But there are still some applications that even IO2 can't support without having to combine multiple volumes. For these applications, customers have historically had to rely on storage area networks or SANs. SANs network many different block devices together. They have been popular for large on-premises applications because you can scale the total storage capacity by adding more storage volumes to the network, and you can get very high IOPS performance by storing and retrieving data from many volumes in parallel. However, SANs have a bunch of drawbacks. Multiple applications share the network to store and retrieve data, so sometimes applications experience variable performance. They also require a lot of management to set up and maintain, and because you have to bunch all of these additional hardware and software for the network, they are much more expensive. We wanted to provide all of the storage capacity and IOPS performance of a SAN without the cost and maintenance and management. And we wanted to reinvent EBS to deliver a block store with the performance of a SAN, but with all the benefits of the cloud. To address this, at reInvent 2020, we introduced IO2 Block Express, the first SAN in the cloud. With IO2 Block Express, we are providing the best single volume IOPS and throughput in the cloud. IO2 Block Express increases performance over IO2 by 300% with up to 64 terabytes capacity and 256K IOPS and up to 4,000 megabytes per second per physical core of throughput. In addition to IO2 Block Express, provides consistent sub-millisecond latency with 99.999% of IO operations completing in less than 10 milliseconds. IO2 Block Express is ideal for your largest and most IO2 intensive mission critical deployments of Oracle, SAP HANA, Microsoft SQL Server, and SAS Analytics applications that today you run on a SAN. IO2 Block Express is available in preview today, and in the next few months, we will continue to release additional SAN features, including multi-attach, IO fencing, fast snapshot restore, and elastic volumes. With IO2 Block Express, you can scale and provision volumes in just minutes that meets the IOPS throughput, durability, capacity, and low latency requirements of your most demanding applications. Customers that need sub-millisecond latency or need to go beyond the current single volume peak performance and throughput can sign up for a preview of the IO2 Block Express, which are IO2 volumes running on Block Express. Designed to provide 4,000 megabytes per second throughput per volume, 256K IOPS per volume, and up to 64 terabytes of storage capacity, along with about 1,000 IOPS per gigabyte, as well as 99.999% durability and sub-millisecond latency. IO2 Block Express offers the highest performance block storage in the cloud. With IO2 Block Express, customers can now get SAN-like performance in a highly durable block store in the cloud with the ability to scale, provision, and pay for just the capacity they need. Block Express is the next generation of Amazon's EBS storage server architecture, purpose-built to deliver the highest levels of performance with sub-millisecond latency for block storage at cloud scale. Block Express does this by using scalable, reliable datagrams, a high-performance, low-latency network protocol to communicate with Nitro Systems-based EC2 instances. And this is the same performance and low-latency network interface that is used for inter-instance communication, EFA or elastic fiber adapter, which is used in high-performance computing and machine learning workloads. Additionally, Block Express offers modular software and hardware building blocks that can be assembled in many different ways, giving us the flexibility to design and deliver improved performance and the new features at a much faster clip and rate. During the preview, IO2 Block Express is supported by R5B instances, with support for other Nitro-powered instances in the works. So it's worth looking into some of the R5B instances as well. Well, you see, R5 family of instances are memory-optimized instances and are designed for memory-intensive applications such as high-performance databases, in-memory caches, real-time big data analytics like SAS Analytics, and other enterprise applications. At re:Invent 2020, we introduced the availability of R5B instances, a new addition to the R5 instance family, which is powered by the AWS Nitro instances to provide the best network-attached storage performance available on EC2. This new instance offers up to 60 gigabytes per second of EBS bandwidth and 260,000 IO ops per second. Customers operating storage performance sensitive workloads can migrate from R5 to R5B to consolidate their existing workloads to a fewer or smaller number of instances. This can also reduce both the cost of your infrastructure as well as licensed commercial software working on top of those instances. Right now, R5B instances do not support IO2 volumes or IO1 volumes that have multi-attach enabled, which are coming soon. Great. Now that we have looked at R5B instances and IO2 Block Express, let's take a look at some of the performance numbers of the tests that we had talked about earlier. Well, there's a famous saying that not every workload will yield the same result. So to test that hypothesis, we validated the max EBS bandwidth for each of the R5B instances against IO2 Block Express. Our goal was to come near the 100 megabytes per second per physical core requirement, but almost all of our configurations exceeded that requirement. To test this, we provisioned all R5B instances from smallest to largest in US East 1, which is Northern Virginia, on a Red Hat Enterprise Linux 8.0 version and added a 40 terabytes IO2 Block Express volume. We used variable IOPS for the majority of the configurations, And we also knew from previous customer engagements that SAS workloads typically run between 4x large to 12x large instances, which is between 128 gigabytes to 384 gigabytes of RAM, and provision IOPS at 5K, 10K, and 15K respectively based on instance properties. We also updated the read ahead setting from 128 kilobytes to 256 kilobytes. And for all of these instance types, we successfully exceeded the 150 megabytes per second per physical core throughput. This is a remarkable achievement as no combination of EC2 instances and single block storage volume could give us that performance in the past, which means no striping volumes and no additional management overhead or consistency issues. Whether a customer is performing a SAS 9.4 lift and shift, a SAS grid migration, or a brand new modernization to SAS VIA, the new IO2 Block Express will far exceed what you're accustomed to with AWS. Wow, that was a lot of numbers and a lot of IO logic. We do believe that now with IO2 Block Express, it is possible to build your favorite clustered file systems on Amazon EBS that meet the high performance requirements of the SAS workloads, along with file systems such as GFS2. At this point, the team is working really hard to enable features such as multi-attached elastic volumes, fast snapshots, and IO fencing to ensure that your clustered file systems like GFS2 can reach any and all type of workload requirements. Let's now talk a little bit about price. On-prem, if you get a good deal on a SAN, you might pay about 100K. And with maintenance and support, that number can easily go up to 200K. And if you want to add additional storage, you'll have to pay in increments of $200,000 along with maintenance and support. Compare that to the ability to provision on-demand version cheaper than its current storage requirements that you have on premises, along with provisioned IOPS and storage that you can get on demand. This can easily be estimated using the pricing calculator, for which I have provided a link. We did also conclude that to get the right balance of price and performance, you could go with a lower provision block express that can help meet your throughput needs. So feel free to please lower your IOPS configuration to less than 10K IOPS range to find the throughput that meets your price and performance requirements. At the end of the day, we want to ensure that customers running SaaS workloads find the best price on the cloud on AWS. With that, I thank you for listening and welcome your feedback and comments. We're always looking for your inputs from SaaS customers and partners, so please feel free to email me at rajand@amazon.com. Thank you and have a great day.